In this video, we want to talk about some common reasons that routes might not be appearing as expected in our IP routing table when we're running OSPF on that router. One reason is that the area to which an interface belongs, and we're trying to advertise the network for that interface, maybe that interface is in an area that is not adjacent to the backbone area. Remember, with OSPF, we're supposed to have a backbone area to which all other areas connect. We call it area 0, or sometimes people configure it as area 0.0.0.0, but I'm just going to call it area 0. Any other area needs to be adjacent to that area. For example, if I had an interface participating in area 2, and in order to get from area 2 to area 0, I had to go through area 1. Area 1 was a transit area. That's not a valid configuration because area 2 is discontiguous from the backbone. There is a workaround for that. It's not a best practice. It's not something you want to design in from the beginning, but it's a workaround I want you to know about. We could have something called a virtual link. A virtual link allows us to logically span a transit area. We can go into the ABRs, the area border routers on each side of this transit area, and we can configure them for a virtual link. So in the example I was giving, area 2 can appear to be adjacent to area 0. It's going to go over this virtual link, which makes it look like a direct connection into area 0. A virtual link is a workaround, not a best practice. Maybe we have a more believable routing source. If OSPF says, here's how to get to this network, and EIGRP says, here's how to get to the same network, the router by default is going to believe EIGRP because it has a lower AD. It's got a lower administrative distance. Remember, the default administrative distance of EIGRP is 90. With OSPF, it's 110. It's not as believable. And we might have a directly connected network. We might have a statically configured network. They could also be more believable than OSPF. Now, keep in mind that we can go in and alter the administrative distance of a routing protocol if we want to. I could go into router EIGRP configuration mode or router OSPF configuration mode, and I could give the distance command, and I could set the AD, the administrative distance, to a non-default value. But that's one reason that a route might not be showing up as expected. It's not as believable as another route pointing to the very same network. Another reason we might have OSPF routing issues is we're filtering routes. And filtering works a bit different with OSPF than it does with EIGRP, and I thought it would be a good use of our time to discuss OSPF route filtering, and then we'll jump into a trouble ticket. Let's think about why we might want to do OSPF route filtering. We might want to do it for security reasons. For example, maybe we don't want a router to have reachability to a particular network. Maybe we're trying to reduce the size of the IP routing table in a router by eliminating any unnecessary routes. Maybe we're trying to prevent a routing loop. And the question comes up, how do we filter these routes? And there are three primary ways we can do this. And to illustrate these approaches, let's imagine a topology where we've got a backbone area, area 0. We've got area 1, and one of the routers in area 1 is also connected to an EIGRP autonomous system. And remember, a couple of these routers have special names. The router that has an interface in area 0 and another interface in area 1, it's called an ABR. It's an area border router. We also have a router that's an ASBR, an autonomous system boundary router. It has at least one interface in an OSPF area and at least one interface in another autonomous system. In this case, it's an EIGRP autonomous system. And when we're doing route filtering with OSPF, typically we'll do it either at the ASBR, as a route is coming in from that external autonomous system, or we'll do it at the ABR between our areas. Let's imagine that we've got a network in area 1, and that network is being advertised into area 0. And let's ask ourselves, how is that network going to show up in area 0? It's going to show up as a type 3 LSA, which is generated by the ABR. Let's say we've got a network in the EIGRP autonomous system, and it's being advertised into OSPF. Well, it's going to be advertised via a type 5 LSA that's generated by the ASBR. And because of the way this works, an ABR might be a very appropriate place to filter a type 3 LSA. We can do that with a filter list. And the ASBR, it could be an appropriate place to filter a type 5 LSA. And that's going to be done as part of a redistribution configuration, something we'll talk more about in our next module. But there is another approach. Let's say that we want to filter a route from just one of those routers inside of area 0. Is that even possible with OSPF? Can we tell OSPF to have a different link state database for just one router in an area? No, we cannot. That's not allowed. In fact, that violates one of the basic concepts of OSPF, where we're saying that every router in an area needs to share the same link state database about that area. They need to agree on what the topology looks like. What are the networks in that area? We're not going to be able to selectively filter routes out of an OSPF database for just one router in an area. However, what if we did this? What if we let OSPF go ahead and learn that network that we're wanting to filter out? OSPF knows about it in its RIB, its routing information base. Well, remember that just because OSPF knows a route, that's no guarantee that that route is going to be injected into the router's IP routing table. The route learned by OSPF is just a candidate to be injected into the IP routing table. So what if we did this? Before OSPF could inject that route into the IP routing table, we blocked it. Specifically, we can configure something called a distribute list, and that can be used to block that route from being injected into the IP routing table while letting that route stay in the OSPF database. OSPF knows about the route, but the IP routing table does not. Those are the three primary approaches to OSPF route filtering that we might need to keep in mind as we're doing troubleshooting if we're trying to determine whether or not a route has been filtered. Now, let's go out to a live interface and troubleshoot an OSPF routing issue. In our last video, we resolved a couple of OSPF neighborship issues in this topology, but just because I've got those neighborship issues resolved, that's not a guarantee that my routing is working as expected. For example, I noticed that on router R3, I'm unable to ping the fast Ethernet 0/0 interface on router R1. Let's try. Let's do a ping to 192.168.1.1. Can I get there? It's not looking good. Now, what's particularly curious about this is I do seem to have a path to R1. I can get to its other interface. Let's confirm that. Let's do a ping to 192.168.2.1. This is the fast Ethernet 0/1 interface on router R1. Looks like we had an ARP timeout, but you can see that I do indeed have connectivity to router R1. So what's going on here? I've got OSPF configured on all of my routers. I thought that I told OSPF to make all of my interfaces participate in the OSPF routing process. Well, here's a way on R3 that we can peer into the OSPF RIB, the routing information base, to see exactly what it has learned. What networks does it know about? Let's do a show IP OSPF RIB command. Do I know about the 192.168.1.0 network? Oh, look at this. I actually do know about that. I know about that, but I don't seem to be able to get to it. Let's look at our IP routing table. Remember, a big point we were making is that just because OSPF knows how to get to a network, that doesn't mean that that route is going to be injected into the router's IP routing table. And in this case, it's not. Look at this. There is a different route in the IP routing table that says, here's how you get to the 192.168.1.0/24 network. It's directly connected to null 0, which goes nowhere. Oh, that's a statically configured route. Maybe we did that to prevent traffic, maybe for security reasons. Maybe we wanted to prevent traffic from going from router 3 to that network. But let's say that we've determined that's not what we want to do. We actually want to be able to get to that network. Well, the way to resolve this is we need to get rid of that static route. Remember those reasons we discussed earlier on that said we might not be able to learn a route because we were filtering a route, and we talked about some other reasons. One of those reasons was there's a more believable routing source. And in this case, that more believable routing source is this static route. Let's fix this. Let's go into global configuration mode, and let's get rid of that static route. In fact, let's look at that static route, and then I'll just negate it. I'll say, let's do a show run pipe to include IP route. That's the command I want to get rid of. So I'm going to negate that. Now let's see if we know a better route via OSPF. Let's do a show IP route. That looks much better. It says that we now know how to get there via OSPF. Do we have connectivity now? Let's try. And we do. Fantastic. We resolved our connectivity issue, our routing issue, by getting rid of that more believable routing source, which in this case was a static route.